Hello to viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about f-stops versus t-stops. So let's dive deep into it. So what is f-stop? Now f-stop is a basically mathematical formula that allows us to figure out at a glance easily basically how much light is falling into your sensor or film, whatever have you, and it applies for both stills or video. It does not make any difference, and it has the same steps formula that is applied on ISO and speed. Speed as in like you have 1/60th of a second, 1/80th of a second, and 500th of a second, 1/200th of a second. The same logic basically. And ISO is like 400, 800, 1600, same logic. So what does that mean? Stops. Whenever you hear about this stop in photographic term, what does that mean? That simply means one thing. If you go one step up, that step will be taken away from you. You will not have the choice to go between them. Step will be double or half. That's how it works. So it's very easy, very quick. That's why we selected this in basically photography. So if you know your film stock, basically back in the days when this was popular, if you knew like this is ISO 200, everything else was like very quick. It's like ISO 200, I cannot go like, let's say 1/500th of a second. You will be like, okay, so I have ISO 200, so I can only go to, let's say 1/30th of a second or something like that. You will know precisely very quickly, and the camera will not actually allow. And yes, this is an ancient camera, and yes, it does not allow you to go in between. Even modern digital camera, in principle, they can give you, but from a usability point of view, they generally lock that option away. So that's the whole point. Stops is a very simple way, like, but we needed to figure stops ISO. Okay, that's your camera sensor, you can't change it. And yes, there is no setting as ISO in digital, unless you have two circuits where company will never shut up about this. So they'll be like, we have dual gain circuits, of course. Then you will have like 800 ISO and 1600 ISO. What about all other numbers? Yeah, those numbers are made up. You can shoot at 800 ISO and just keep increasing in post. It will make the same thing. Especially if you have RAW, not on JPEG. Do not apply on the JPEG, it applies on RAW. Sensor only has one setting. And speed, yeah, that's the how you control the main thing. 500th of a second, 200th of a second. So speed is your true control. And film days, you could not even change it. So ISO, nobody even bothered about it. It's like back in the day when you had this sort of camera, there is a knob here where it's like, okay, what is your ISO setting? Just put that number here and just forget about it. It's just like, oh, ISO 200, adjust everything accordingly. You can't change it unless you complete the role. So for that reason, we needed another vector, which like we got the temporal, meaning time. That is the shutter speed. How do you control the quantitative of it? Quantitative was f-stop. That's how we created it. So how do we come to this number f-stop? F-stop is very cleverly derived from basically focal length, how many mm it is. For example, in this scenario, it would be f735, I think. What the heck? F75. 75 mm, and then you will calculate it basically by diameter of the intrus aperture. So in simple example, it will, let's say lens is 50 mm focal and the intrus diameter is 25 diameter wise. That would be f2 point lens. That's it, f2 lens, that would be f2. So it's a division number, and that's why you can have f2.8 in basically wide angle or telephoto. Telephoto has 300 mm, but to achieve that, that's why you'll see a telephoto lens that is like, let's say 400 mm and has f2.8. It's huge because they have to make sure this diameter is huge enough to achieve f2.8 or f2. So for that reason, this is a ratio. You have to be very mindful. It's not fixed thing, it's ratio, and the ratio was designed in such a way so it becomes comparable to everything else. For example, f1.8 or f2 or f2.8, these things become interchangeable. So it's like, oh, if you have f2.8 in let's say 400 mm, you should have the same exposure setting. Even if your lens is like, instead of 400 mm, it becomes 50 mm, more or less. Now be mindful, when you have wide angle, you have more light sources falling onto your lens, so fundamentally your exposure does go a bit up, so you have to compensate for it. So that's the whole point. Every lens will become simplest mathematical terms. So you will have like your mobile phone, your micro four third, your APS-C, your full frame, your medium format. So all those things will have f-stop. Everybody would be standardized. Everybody would be happy with this. However, let this be very clear. While I'm talking about the entrance and exit, the sub variables inside it is huge. And be mindful, f-stop it's kind of incomplete if you do not know the angles, and you're like, wait a minute, what the heck is angle? Yeah, that's the whole problem. That's why your mobile phone can also have f1.2 lens but does not give the same feeling of basically f1.2. So there are too many sub variables. This is a very simple mathematics. For simplicity's sake, for ease of use sake, we have settled on this. You have f1.4, f2, f2.8, and you may like, okay, this number sounds odd, like why the heck we are going from 2 to 2.8? It's one stop, and you do not have to worry about this. Your lens will be locked into that. So for example, old days when we had like direct aperture ring, it was mechanically locked. You could go in, like this is a physical shutter, so you can physically shrink it, but for ease of usage, they were like, okay, you have f6 f5.6, you go one stop up, as in like you half the light, so you go to f8. You do not go like f6.7. While in cinema lens you can do that. It would be like, and even in some photography lens where they had declicked it, meaning it will not stop in these things, you can easily smoothly change it. So this is the f-stop. It's a mathematical construct derived by entrance and focal length. That's all you have to worry about. So this directly affects what we call depth of field, meaning the background blur and how much light is falling on the sensor. These are the two variables that you have to control. So when I talked about that, it's about angle. This is the best example I could find. So when you have a lens, and that's why you must have noticed, like you cannot actually increase the aperture. So if lens is f2.8, you buy f2.8 lens. You cannot be like, I bought f3.5, what if I increase it? You can't. ISO you can go just keep increasing to ludicrous level, and shutter you can slow it down to get more light, but in aperture you are limited. It's physically limiting vector. So let's say this is your aperture, you select focus on something, and voila, the light goes here, and then you have an angle. Now this angle, that's all you have to focus on. That means you have focus, everything is fine. But here's the deal, what happens if you shrink the aperture? So let's say f3.5, you drop it to f2.8, or not drop as in like f8, f11. What happens then? Then your aperture shrinks, meaning it rejects light that are not falling. So the angle that is available becomes completely wider. So now you have much bigger depth of field. So that's awesome. You can focus a lot more things. Like here's the, if you have full lens, you only get this focus, everything else is out of focus. But if you like shrink it down, aperture, this is f22, now you can see everything in focus. You can see so much detail, everything is awesome. But you can see you shrink it here, like in physical lens sense, you literally block the light. So this fundamentally has less photons. This gives you more photon, meaning your ISO will go down. If you have, let's say, ISO 200, you have to use this puppy. If you have, let's say, ISO 1600, you can use this. So depth of field, of course, you may be like, hey, I need, let's say, large depth of field. Let's say you are a landscape photographer. Of course, you need this. In those scenarios, you also have to worry about, okay, how you gonna take care of other vectors. For example, shutter speed. So this will reduce your light. So how do you compensate? You increase your shutter. So instead of, let's say, 1/200th of a second, you may be like, hey, what if 1/100th of a second? That's it. So that's how we take care of this situation. So be mindful, it's the angle that you have to worry about. Everything else is secondary, it's just the angles. The ratio of control of basically how much light fall off is there. And there is another factor. Whatever lens you take, whatever lens, it only has one focal plane. It does not have, oh, this much is in focus, this much is in focus, or this. No, it just have one two-dimensional pair where angles are crossing perfectly. That's perfectly in focus, perfect. But what happens if you go a little bit, like let's say this lens that you are using, it has perfectly focused here. What happens if you go below it? You can still see this, then how the heck that's possible? Well, the fall off is gentle, so to say. So if fall off is extreme, then you're like, okay, I'm here focused, this will be blurry. And sometimes again, especially with if you have, let's say, f1.8 lens, you can actually achieve a scenario where eye and eyelids could be out of focus. So you have to understand, background blur is directly proportional to that. And the smaller number is bigger. f2.8, big. f3, not big, it's small. f11, really small. f22, hyper small. So be very mindful, the number are inverted because you are getting this number by dividing, so it's inverted. So smaller number equals larger hole equals more background blur, but you also shrink your depth of field. So if you have to take a very, let's say, landscape photography or something where you have to focus on a lot of things, you may have to compromise. You physically cannot do that, you have to increase your shutter. And then larger number is completely opposite of larger number, like f11, f8, f22. That simply means holes are smaller and you get less background blur. However, you get much better depth of field, desirable. So how quickly the fall off happens from perfectly mathematically perfect point defines how much things ahead of the lens you can see, how much things behind the lens you can see. This is all determined by the angle, and be mindful it's not completely symmetrical. So meaning ahead of the lens generally is much sharper fall off compared to the behind of the lens. So these things happen. And back in the days of like 1960s and 70s, all lenses used to have like markings where it's like, oh, it's a 9 foot 0.9 foot 1 foot 1.3 foot 1.5 foot, and this lens is going back and forth. You can easily do that in ancient cameras. Oh, even many cinema lenses have this sort of distance rating directly marked into it. You can see that. So focal plane is always fixed, two-dimensional, but the fall off defines how much 3D depth focus you have. You want a lot of things in 3D focus, you will use high depth of field. You want like only the person in focus, everything else disappears, you want shallow depth of field. That's how it works. It's angle, not the mm. Let that be very clear. It's all about angle. For example, if you have, let's say, a camera like this, like, Density point and shoot camera, you have something like this and you're like, how do I get like, very good aperture photo? Well, let's say you go to a mountain top, especially find an interesting background, have your person, put this as far as you can and then shoot the photo. It will look like, whoa, especially in daylight. So the aperture, basically shutter speed in this can goes down. So you have less motion blur. People will like, whoa, it looks professional. That's the whole point. Distance controls more how the field looks rather than the aperture. Now, of course, you cannot control the distance. For example, if you want to take a photo of a cricketer, you're not going to go next to him. You are limited. In that scenario, we have to use basically different mm. So be mindful. All these vectors are interlinked to each other. You change one, other automatically changes. So distance to subject is the biggest factor. How do you get, like, basically if you remove the object itself, physically move the object itself further back, you will find amazing result. For example, photographers who are photographing things that are like, played in large courts like football, cricket, they will have awesome time. They will buy f 5.6 lens and they're like, whoa, awesome. But if you compact that, let's say tennis, or you compact it even for table tennis, you'll find, dude, the background blur on the same lens, f5.6 lens, will not be as awesome. So be very mindful of the distance to subject has the biggest direct effect. And it does not tell you how much light falls through. Of course, it mathematically tells you like, oh, this was the maximum option, now you shrunk it down. It mathematically tells you, but again, real world is not 100%. So how much are you actually getting? That's the problem. It calculates the depth of field, awesome. It tells you how to get your aperture, basically other vectors, awesome, but does not tell you how much light is actually passing through. That's the biggest issue. So we invented a new system known as T-stops. Now T-stops is basically called transmission. Now transmission is a realization of the fact that no glass is 100% transparent. Physics does not allow that. If you ever seen any reflection on glasses, mirror lenses or something like that, you know, like, okay, if you're seeing it, if it's not absolute black, that fundamentally means some photons are bouncing back, and it's just bouncing back, and there are some photons are also absorbed. So in this sort of scenario, you have to understand that your lens f2.8 physically cannot give you f2.8 equivalent of photons. Photons will always be lost. So if you have 100 watts of photon falling here, how much is going to the sensor will always be less than 100, even though mathematically it should be. So you have to understand basically the quality of the lenses, coating applied on the lenses, all of that. So mathematical ratio f2.8, awesome, but how do you get the efficiency? So we created this T-stop, which is f2.8 plus the loss. How much loss is there? That gives you T-stop. So that's why T-stops will always be basically higher. So let's say you buy a Canon lens, Canon RF lens, that is 16mm f2.8. That's awesome. But what is the T-stop here? Again, you have to add loss and you cannot exceed 100%. So that simply means the T-stops are something lower than that, lower than f2.8, which is 3.1. Now, here's the issue. The loss is not fixed, meaning you can take, let's say Canon 16mm. Again, in different mounts, it will have different transmission. So that creates an issue, like very serious issue. This is why we do not use this for photographic lenses, meaning you buy a point and shoot camera, mirrorless lens, whatever have you, they never mention the T-stops. That is the primary. T-stops requires external measurement. Many times you will find generally prime lenses to have very good transmission and zoom lenses to have horrible transmission, because the more glass you have, the more light you are losing. Law of physics, you cannot bypass that. Even though on paper you'll be like, oh, this is f2.8, in real life sometimes it could be so worse where it's like, dude, your transmission is f4. Now, of course, F4 level photons are present. We do not call it F4, we call it T4. So cine lens is the industry where we use this T-stops. Why do we use it in cine stops? Well, very simple. You want to make sure if you're switching cameras, each camera generally requires a lens, and every time you change the shot, you generally do not zoom in, you switch the lens. Let's say you go from 20 millimeter to 50 millimeter, 50 to 35 millimeter, 35 to 85 millimeter. If you're switching like this, all of these lenses have to match up. Now, in real world, they cannot match up. So how do we make sure, like if we say f2.8 it would be different in this, f2.8 in this different, in this different, in this different. So engineers came up with the transmission. So now the lenses are measured and then they are marked. So if basically this says f2 or t2, you can be damn sure the transmission efficiency is exactly matched to T2 of 50 millimeter, T2 of 85 millimeter, T2 of 35 millimeter, T2 of 45. It will always match. It will not be have the issue where it's like, oh, I had Sigma f2.8 and I had Tamron f2.8 and they look different. Why do they look different? In terms of brightness, scene brightness, you must have controlled everything, but you're like, dude, the scene brightness is fundamentally different because the lens is not transmitting. So you can see the size difference. This is f1.2, this is t1.3. Now this may create an issue in your brain where it's like, wait a minute, this is f1.2 and we cannot achieve 100%. So is it really that good to achieve like almost t1.3? No, what they did is just basically make it bigger. That's why these lenses are fundamentally bigger. So even if you look at, oh, this is t1.5, does not mean it's f1.5. It means it's f1 or f1.2. So generally the f-stops are much larger in these sort of lenses, and they do not expose that data to you because it's no point. So all the cinema lenses generally say what is the t-stop, like this is t2, this is t1.5, that is t1.5. That means that's the rating. You do not have to worry about it. Your exposure will match. So that's why we use transmission. Basically, you take the f-stop, add the loss to it, get the t-stop. But it's completely different in every single lens. Every single inside a brand could be different. Heck, multiple batches could be different. So for that reason, these things have to go through extensive testing. So these are not just like, oh, we mathematically calculate, then we are stamping it. No, no, sir. You have to test it. And that's why the lens price will go on from $500 to $5,000. I'm not joking. The prices on these puppies are bonkers. So what are the uses of this T-stop? Well, in your everyday, day-to-day life, you do not have to worry about it. F-stop is more than enough, and that's how you control your depth of field. Basically, how much a depth of field is. That's how you control it, F-stop. So why the hell worry about T-stop? And T-stop is basically not interchangeable as the same way you will think. Basically, if you have a cinema setup, basically you are doing a shoot and you are gonna swap lenses, yeah, it matters. But how often do you do that? Like, of course, in day-to-day life, not I'm talking like cinema, that's what they do, that's their job. But how often do you do that? And how often you like, okay, I'm gonna pay 10 times more for something just so I do not have to do this in post-production. But in cinema industry, of course, they pay for color, they pay for lighting. So they're like, dude, we have to capture the best way possible. So to capture the best way possible, to make sure the lens is not a variable, lens becomes a constant. For that reason, we have to use this in that. Basically, matching in post-production, can it be done? Absolutely. Can it be done with basically digital cameras? Easily, specifically with digital camera. Especially if you have post-processing, the colorist can actually match it. If, let's say, you are shooting in low budget, you do not have cinema grade lens, you will have this issue, and colorists are trained to how to match that. But it's always unwise. Ideally, you should never do that, simply because every digital camera, whichever camera you choose, have what we call base ISO. At that base ISO, it's perfect, meaning you put mid gray up, it will give you maximum dynamic range on top, same amount of dynamic range bottom also. So let's say it's 10 stop dynamic range, you get T5, basically 5 stops above, 5 stops below. Awesome. Now you change the ISO. Let's say you're going from basically wide angle, which generally have good transmission, to telephoto, and now you're like, hey, we have to increase the ISO to 1 step. It will fundamentally look different. Now, is that an issue? For YouTube, no. For TV shows, nah. For an IMAX camera, yes. So that's the reason why we generally go through that much hassle. So matching in post is unwise. You will know. So for that reason, we are like, hey, let's just pay for it. And not to mention, you cannot know the T-stops of lenses, specifically photography lenses, meaning I cannot find out what is the T-stop of this puppy. I have to actually get it certified by a scientific institution. Only then I can know. So there, back in the days, there was a organization, DxOMark. They actually used to do transmission testing, sharpness testing of all the lenses, but they did not make as much money as they needed to do all the testing and calculations. They kind of fizzled out. They're still there, you can still go. Some modern lenses are still added, but they are no longer as precise, as thorough as they used to be. You cannot know about t-stop. For example, you're like, hey, which has more t-stop, which has better brightness, like Sony lenses or Tamron or Sigma? Let's say whatever you do so much in low light photography that you're like, hey, having brighter transmission is much more important to you than raw sharpness. You're like, hey, if Sony is sharp, I do not need it that sharpness if it's, low light. I need a lens that has good transmission. You were like, hey, let's say Tamron, to keep the cost down, they reduce the glass elements. It's not as sharp, but it has very good transmission. You're like, shut up, take money. It would be ideal. It would be awesome to know all that information. But unfortunately, we do not have that information. So you can find all the MTF charts, but you cannot find T-stops as quickly as we would have needed. And the only source that I knew was DxOMark, that no longer provides it. So that's the tragedy. That's why I do not focus too much on T-stops. For day-to-day use, don't worry about it. For calculation, learning photography, it does not matter. If you are in cinema, you have the budget and all that, you don't have to worry about it. So the T-stop is something that looks good, awesome, good to know, but it's not really useful. Unless you are in that industry where you're like, bro, we already have it. So this was my presentation on basically what is the difference between T-stop and f-stop. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra support. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.